All right, in this video we're eliminating complex fractions. So the instructions are just going to say to simplify. And these problems can look pretty simple, and these problems can get to look really complicated. And so this is I picked up on solving these this way or simplifying these this way from another calculus teacher. And it was like, oh my gosh, that's so much easier than what I've been teaching all along. So I think you might want to fight it mentally at first, but it's very helpful. All right, so example 1, we're going to say 4 minus 2/9 over 3 plus 4/3. And I think a lot of people would want to get a common denominator and that sort of thing, and then maybe keep it, change it, flip it. But this way is so much easier. To eliminate the complex fraction, so that means to get rid of these like little fractions within the fraction, we're going to multiply on the top and the bottom by the common denominator. So here we have a denominator of 1, 4 over 1, 3 over 1, so that doesn't really contribute much. But here we have a denominator of 9 and a denominator of 3, so that common denominator is 9. And so we're going to multiply by the common denominator and then go through and distribute that. So the reason this is working is because I'm taking this whole fraction and I'm multiplying it by 1. 9 over 9 is 1, and that's why this works. So now I've got 36 minus, the 9's cancel and I just have 2. 9 times 3 is 27 plus 4. So that's 34 over 31, and I'm done. Clearly not the only way to do the problem, but definitely probably the fastest way. All right, example 2. So here we've got 1 plus x to the negative 1 over 1 plus x to the negative 2. So this is a complex fraction, and it's really not even recognizable because of those negative exponents. So the first thing I'm going to do is rewrite it. And now I can see that it's that complex fraction, and so I can multiply by the common denominator. So I've got denominator of 1, doesn't contribute, denominator of x squared, and so that means that the common denominator here would be x squared. So you can put those parentheses or not, it doesn't really matter. So if I go ahead and distribute this, then I'm going to have x squared plus, and with x squared times 1 over x, one of the x's is going to cancel, and then we're going to have 1 left over. And then when I distribute here, I'm going to have x squared plus 1. These x squareds do not cancel. If you wanted to see if anything could cancel, you would have to factor the top and the bottom. The top has a GCF of x you can factor out. And then now you can see nothing cancels. So this right here is a good answer. The second one is a good answer as well. You might see that as a multiple choice answer, you might not. All right, example 3. X to the negative 1 plus y to the negative 1 over x plus y. So again, we can't really see that it's a complex fraction until we rewrite it. So here the common denominator would be xy. So if I distribute 1 over x times xy, the x's would cancel and we'll just leave a y behind. 1 over y times xy, the y's would cancel and we'll just leave an x behind. And then on the bottom, you can distribute the xy, but then you're just going to have to factor it right out. So what I'm going to do is I'm going to write the bottom as x plus y times xy. I'm going to write it like that. And the reason is because I can see the whole top is the same as this factor on the bottom. Now, it would be possible you couldn't really see that, and so you could distribute it and multiply and then realize it and cancel it. So I'll go ahead and cancel these, and my final answer here is going to be 1 over xy. All right, so all those were relatively simple looking. This next one is going to be kind of getting into the nitty-gritty of this is where you would see this in calculus. So I've got 2x times 2x minus 1 to the positive 1/2 minus 2x squared times 2x minus 1 to the negative 1/2 all over 2x minus 1. Okay, so this doesn't even really feel recognizable as a complex fraction, but it is because of this piece right here. So what I'm going to go ahead and do is I'm going to write this in terms of roots or radicals so you guys can kind of see what's going on. So I'm going to say this is 2x times the square root of 2x minus 1 minus, and then this part I'm going to write as a fraction. So 2x squared on the top over the square root of 2x minus 1. And then on the bottom we have that 2x minus 1. So for this problem, if we're going to eliminate that complex fraction, we need to multiply by that common denominator. And here this just has a denominator of 1, and this just has a denominator of 1. So the common denominator really is just that radical. Okay, so I'm going to get another sheet of paper. Sorry. Okay, so if I take this and I multiply it by the first piece, I still have that 2x in the front, but now the radicals cancel out and I just get the 2x minus 1. Okay, so square root of 2x minus 1 times square root of 2x minus 1 is just 2x minus 1. Minus, and then over here, when I multiply something over the square root of 2x minus 1 times the square root of 2x minus 1, those cancel and I just get minus 2x squared. And then for the bottom, I have this group multiplied by that radical. I cannot cancel those out because the top is not factored. Okay, so now to go ahead and keep simplifying, I can distribute. So this gives me 4x squared minus 2x minus 2x squared. And then I keep the bottom the same. And then 4x squared minus 2x squared is just 2x squared. And nothing is going to be able to cancel. It almost feels like if you factored the top it would, but it will not. If you want me to prove it, I'll just write it off to the side. The GCF would have been 2x, and that would have left an x minus 1. Like it feels like maybe something could cancel, but it doesn't. And so here is what you're left with. I would say that's a pretty, not typical in that like that exact problem shows up a lot, but being able to use that algebra skill from a more simple situation and apply it to this situation is a very common example of how algebra can get really difficult in calculus and like what that might look like.